So in my scripts, let's create a new script to control this battery drain. So right click, create C# script, and let's just call this battery power. Okay, so just double click to open this one. Now we are going to be using the UI, so using Unity Engine.UI. So the first things that we need are a couple of serialized fields. So the first of the serialized fields is going to be of a type image, and we'll call this one battery UI, so that we know the difference between an actual battery pickup and the user interface battery. Okay, and that's the image that we've just put in there. We're also going to serialize another float, or serialize something that is going to be of a type float, and this one is going to be called drain time, or the total amount of time it will take to drain the battery. I'll begin on something really small, like 15 seconds. Okay, so over 15 seconds that will totally drain. Okay. So what we're going to do now, just to test this out, just to make sure that it works, we're going to come down to our update, and we're simply going to say battery UI dot fill amount minus equals 1.0f, so in other words 1 unit divided by drain time multiplied by time dot delta time. Okay, so I think this is the first time that we've used time dot delta time. You can actually go into the scripting reference. Let's just open this, and let's put time dot delta time. Have I spelled that right? I think I have. And then obviously this will tell you, so the complete time in seconds since the last frame. Okay, and that's the important thing, it's this in seconds. So it actually keeps your computer at a standard time frame, as opposed to your frames per second count that deviates between one computer to another. In this way, it means basically you're ensuring that all of your scripts are running in real time, not in you know, some kind of like calculated time based on the power or performance of your computer. So if we didn't do this, some batteries on some computers would run very slowly, other batteries on other computers would just go down like immediately. Okay, so this just keeps it standard. Great, so that will allow the battery to go down. So I'm just going to save this, and I'm going to apply this to the canvas. So I'm just going to drag it onto the canvas, and if we go down, we can now see that there's a battery image required, so that's going to be our foreground. Now have I called those buttons? I have, haven't I? It should be battery. Okay, let me just rename this. BG button, it should be BG battery, and FG battery. The foreground battery should be the one that's image type of filled. Okay, so on the canvas, just make sure that it's still associated. It is. Drain time of 15. Okay, so maximize on play. I'm just going to test this out. It might look a little bit choppy on this capture card. And there we go, it's actually draining down now. So over a total of 15 seconds, it should reach the bottom. When it reaches the bottom, it doesn't go anywhere. Just obviously, it comes down to like 0. You can't drop below 0. Great, so that's working. We're going to keep it a drain time of around 15 for now, simply so that we can preview this as we go through the game. Now once you're in the actual game, once we've done all of our testing, you want to put this to a more reasonable kind of time, if you like, or an amount. So imagine if, for example, one battery might last, let's say, 4 minutes. So obviously you're looking at sort of 240 seconds. So you just type in whatever value you want and the battery will drain down in that amount of time. Now obviously we don't want it to do that automatically. We need to tie that in with whenever you've got the flashlight switched on and whenever you've got your night vision switched on. Okay, and that's what we're going to do in the next video.